Welcome to your first NAS adventure in Neon Secondary School. For today's science adventure, you will be making a paper torchlight using recycled toilet roll. But before you proceed to make the torchlight, you need to first understand how an electric circuit works. Look at the objects shown above. There is a light bulb, a switch, a battery, etc. What term can you use to refer to this whole group of objects? If you said electrical components, you are correct. The parts of an electrical system are called electrical components. When we join various electrical components together, they form an electric circuit. For electricity to flow in a circuit, you must have two things. First, a source of electrical energy. This could be a battery or sometimes called a cell, or you can use electricity directly from the mains socket. Another criteria needed for electricity to flow in a circuit is to have a closed circuit. This means that there are no gaps in any part of the circuit. The picture on this slide shows a closed circuit and the light bulb is able to light up. An electric circuit can also be drawn as a circuit diagram. Just like how you draw 2D representations of lab apparatus, the electrical components can be drawn in 2D using symbols. For example, to draw a battery or electric cell, you can use two vertical straight lines. One line would be longer and this corresponds to the positive terminal of the battery. The shorter line refers to the negative terminal of the battery. If you have two batteries, you need to draw two sets of the long and short lines. If you are using more than two batteries, you can draw a dotted line in between the two sets of lines. To draw a light bulb, you need to draw a circle with a cross inside the circle. A closed switch can be represented by two unshaded circles connected by a line. For an opened switch, the middle connecting line would be angled upwards so that the two unshaded circles are not connected. Do take note that the circles must not be shaded. So, an electric circuit can be represented as a simple circuit diagram as shown on the slide. It is a good habit to denote the positive and negative terminals of the battery on the circuit diagram. Now that you have learned how to draw circuit diagrams, you will learn about series circuit. Are you able to recall what you have learned in primary school and explain what a series circuit is? In a series circuit, each electrical component is joined one after the other to form a single path for the electricity to flow through. The amount of current that flows through each of the components is the same. For example, if there is 5 ampere of current flowing through the wire, there would also be 5 ampere of current flowing through the light bulb. In a series circuit, if one electrical component is removed or broken, no current is able to flow through and the circuit becomes open. Look at the diagram on the slide. When one light bulb is removed, the remaining bulbs do not light up because the circuit is now open. You are pretty familiar with current as you have learned about it in primary school. What about voltage? What is the difference between current and voltage? To understand voltage, you need to first understand how electricity flows through the wires and electrical components in a circuit. Circuit wires are made of metal. Each metal atom has smaller particles called electrons. The electrons carry a negative charge. To get an electric current flowing through a circuit, electrons in the metal atoms will move from one atom to the next in the wires. Look at the diagram on this slide. The metal atoms are represented by the circles with grey dotted outlines, and the electrons are represented by the moving green dots. As the electrons are moving from left to right, we can say that the electric current is moving from the left to right. In an electric circuit, electrons move from the negative terminal of the cell, go around the circuit, and go back to the positive terminal of the cell. The red arrows denote the direction of electric current. Voltage is also known as potential difference. Potential difference is a measure of the amount of electrical potential energy that is changed into other forms of energy when an electron passes between 2 points in the circuit. This may sound very confusing to some of you, so let's take a look at the next few slides for a more detailed explanation. This slide shows an electric circuit with a cell and a light bulb. An electron is represented by the small blue circle. Electrons would leave the negative terminal of the cell, and when they do so, they have a lot of electrical potential energy. The electron will move along the wire towards the positive terminal of the cell. Along the way, the electron would pass through a light bulb. In the light bulb, some electrical potential energy of the electron would be converted into light energy. After the conversion, the electron would end up with lesser electrical potential energy than before. As the electron continues to move towards the positive terminal of the cell, its electrical potential energy decreases. By the time it reaches the positive terminal, its electrical potential energy would be very low. To summarize the difference between current and voltage, current refers to the rate of flow of electrons, meaning how fast the electrons are flowing through the circuit. However, voltage refers to the amount of electrical energy that is converted into other forms when the electron passes between 2 points. Hence, current and voltage are totally different. When you use an electric cell with a higher voltage, it can make the light bulb shine brighter because it can supply more electrical potential energy to the electrons. This table shows you the common voltage sources and how much voltage they supply. For example, batteries usually provide 1.5 volts, and the main socket in Singapore provides 240 volts. In some countries, the mains sockets only provide 120 volts. So if you bring certain electrical appliances over to other countries, you may realize that the electrical appliance won't even switch on as they are designed to work on 240 volts. To find out the voltage required for an electrical appliance to work, you can look at its label. In the two pictures, the voltage required for the appliance to work is in the red boxes. If insufficient voltage is supplied to the appliance, it would not switch on or may not function well. If too much voltage is supplied, it would cause another problem. The components in the electrical appliance would overheat, and this can lead to the appliance to fail in the long run. The next part of today's lesson will touch on the different types of light bulbs. You should have heard of incandescent bulbs and LED. These two different types of bulbs are commonly found in many households. The other types of commonly used bulbs include compact fluorescent and halogen. Incandescent bulbs are the most common and least expensive bulbs among all. They emit a warm light and are the least energy efficient. This means that they consume more electrical energy to give out a certain brightness of light. They last longer than halogen bulbs, but not as long as CFL or LED. CFL bulbs are able to emit a wide range of colors. They take some time to warm up to get brighter. They are usually used to illuminate large spaces such as ballrooms and basements. CFL bulbs are less expensive than LED. Halogen bulbs emit a white light that looks like high noon daylight. As such, they are commonly used for recessed lighting and under cabinet lighting. Halogen bulbs have the shortest lifespan among all types of bulbs. The advantage of LED is that even though it can emit a bright light, it does not give out heat energy. LED can last very long, up to 25,000 hours. Compared to incandescent light bulbs, LED use at least 75% less energy. Hence, LED is gaining more popularity in recent years. As LED is the most energy efficient among all light bulbs, you will be using LED to make a paper torchlight today. The instructions for making the torchlight will be provided in the next video. Thank you and hope you will enjoy the activity.